694 Hydraulics and Pneumatics. In this subject we are going to see about the fourth unit, that is pneumatic and electro-pneumatic systems. Particularly in that fourth unit we are going to discuss about the ladder diagram in these videos. What is ladder diagram? A ladder diagram is a symbolic and a schematic representation of both the process hardware and the process control. The ladder diagram consists of vertical lines representing the power lines. The circuits are connected as horizontal lines, that is, the rung of the ladder. Between these two verticals, it's called a ladder because all the devices are connected across the supply lines, making it look like a ladder. Each parallel connection is called a rung. It can contains many inputs but only one output. Next, the constructions of a PLC ladder diagram. In this drawing, the circuit line for a rung, input must always precede outputs and there must be at least one output on each line. Each rung starts with an input or a series of inputs and the end with an output. In the left hand side, see the symbols used in the ladder diagrams, that is the input switch as contacts no closed until input. Next one is the input switch normally in closed condition, and next to that output, and final one is the special instructions. The right side is the rungs in a ladder diagram. It shows the two vertical lines. It's a power supply line. In between that, the horizontal line is the rung. Every rung has an output. Number of inputs, that is only one output. It shows the three rungs. First one is the only one input and output A only. The second one is the two input and only output B. And third type is in parallel switch, input 4 and 5. It gives the output C. It is the constructions of ladder diagram. Next one is the what are the symbols used in the ladder diagrams. A push button switch show the normally open condition and normally closed condition. Push button PB normally open, and the second and right hand side is the PB2, that is the normally closed condition push button switch. And next is the limit switch, LS1 normally open, LS2 normally closed. Here you find that diagrams open and normally closed switches, and temperature switch, pressure limit switches, level limit switches, on delay switches, that is normally open and normally closed, off delay switches with the timer contact. How the symbol shows the functions of that buttons and switches. Next one is the output devices. Normally here relay, contactor, motor, solenoid valve, indicating lamp, and the timers. These are all the output devices in the ladder diagrams, normally in open and closed conditions. Diagram shows that how the motor can be fixed. It is a circular and a solenoid valve, it's a sinusoidal curve. Next one is it's a normally open input switches, that is NO, that is the limit switch, and push button, pressure switch, the manual switch, it's a contact switch. Next one is the normally closed switches, it's a limit and push button, you already see that. And the output devices, solenoid or relay coil, lamp, and horn. These are all the outputs. Next one is the PLC ladder program for logic functions. Here that 5 logic functions can be developed by combinations of the switches AND, OR, NOR, NAND and XOR. These are all the 5 logic functions. See one by one. In the diagram you see the OR, AND and NOT logics. Here first one is the OR logic. Input A and B and the output is the Y. That shows the logic A into B is equal to output Y. Placing that in between the two vertical lines, you place that rung switches, input switches A and B, that gives the output. The number of input is 2 and only one output. And the second one is the AND logic. Logic gets A and B is the input, Y is the output. Here that A plus B, that gives the output Y. So first one A and B, that shows the output Y, and last finally the NOT logic gate, the input A, that gives the output Y. And the diagram shows that. Next one is how the logic gates has been functioned. In AND gate, AND logics, it shows the diagram A and B. Diagram A is the AND logic situations, and diagram B is the ladder diagram. Input 1 and 2, that gives the output. The coils is not energized unless both switch A and B closed. Deeply we are going to see that. Here see the diagram A shows the situation where the coil is not energized unless two normally open switches are both closed. Switch A and switch B have both to be closed, which thus gives an AND logic situations. Next the B diagram shows the PLC ladder diagram for AND logic functions. The ladder diagram starts with an input switch that is in normally open condition, that is the input 1, that is been labeled. Then to represent the switch A and is in the series with the input switch, that is labeled as the input 2, normally in open condition. To represent the switch B, the line then terminates with the O to represent the output. So diagram shows that. Next we are going to see the OR logics, OR logic functions. Yes, the diagram shows the coil is not energized until either A or B closed. Diagram A shows the OR logic situation. Diagram B is the PLC ladder diagram, shows the push button A and B and solenoid output. How is it work? The situation where the coil is not energized until either normally open switch A or B is closed. This situation is an OR logic gate. And next PLC diagram for the OR logic shown in the diagram B. The ladder starts with normally an open switch labeled as the input 1 to represent as the A, and in the parallel with another input switch normally in open stage labeled as the input 2 to represent with the switch B. The line then terminates with O to the represent as the output. Placed in the series condition, not in series condition, it is in parallel condition in OR logic. Next one is the NOR logic functions. Since there has to be an output when neither A or nor B have an input, and when there is an input either A or B. So diagram shows the NOR logic situation, A diagram, and B diagram shows the PLC ladder diagram, that is in normally in closed condition, input 1 and input 2, that represent the switch A and switch B. Switch A as input 1, named as input 1 in logic ladder logic diagram, and switch B as the input 2, both of them normally closed condition, and equivalent output O. Show the solenoid switch. And next see the problems. Exercise number 1. Here the water level control. It's a single point level control. When the level is above set point, the output pump should be off. When the level is below the set point, the output pump should be on. The diagram shows that it's a tank. Up to the tank is the pump. It's a set point level. Now the solution for that, there is the number of inputs on pump off and limit switch, that is pump on, pump off, and the limit switch, that is input is equal to 3 input, and the number of output, always how many inputs are available. Here is the 3 input and only 1 output. The condition for input and outputs are tabulated. X1 and X2, X3 are the, X1 is the pump on, X2 is the pump off, X3 limit switch, and gives the output Y1. Shows the various level. X1 is high and X2 low, limit switch as X3 as low, that gives the high output. This the ladder diagram shows that is the 2 vertical lines. In between 2 vertical line is the supply line. In between that we place the rung. First normally open switch, and here place that second one X1 and X2. Here R1 is the relay, act as a latch, and here that second conditions, X1 and X2 is off condition, is then high position, that gives the low output, and final one is the X1 is high, X2 is low, and limit switch high, that gives the low output. This is the ladder diagram, show how the problem has been executed by using the switches, ladder functions, and ladder symbols. Thank you.